So let's get started. 8.6, solving exponential and logarithmic equations. We want to solve equations now. With all this information we've learned about exponents, we've learned about logarithms, how do I solve these algebraically without having to go to my calculator and find intersection points or anything like that? Here we go. This is how we're going to start this. First of all, the first notes you need are these two. This is something we've been talking about. I gave you this first note. Log base b of b is equal to 1. What does that mean? That means log base 5 of 5 is equal to 1. Any number that goes into b is 1. What that also tells me, however, is it gives me this. If I take log base b to the of b to the x power is equal to x. This tells me that my log and my exponent cancel. So all I'm left with is my variable x as my answer. So whenever you have log base 7 of 7 to the x power, the log and the exponent cancel, leaving x. So when we were having problems that said log base 7 of 7 to the 8th, my answer was always 8. Now I said, okay, well, we can move the 8 to the front, and then we can say log base 7 of 7 is 1. But I don't actually have to move the 8 to the front. I can just say log base 7 of 7 to the 8th power is 8. This lets me know that the log and the exponent are inverses. They cancel each other out. So we're going to be using this idea. But in the same way, and this is where things get kind of weird, if I have, so this is my first rule, log base b of b to the x power is x. The log and the exponent cancel, leaving x as my answer. My variable stays the same. That's the first rule I need to know and be able to use. My second rule is very similar. If I say b to the log base b of x, so the log is in the exponent, the base is b, and x is the argument. These also cancel out, leaving x as my answer. This again tells me that the inverse of log is exponent, and they cancel each other out. What in the world am I doing? Well, remember, if I say x plus 5 minus 5 is equal to x, that says addition and subtraction are inverses. I'm doing the same thing with logs. So if I have 5 to the log base 5 of 7, 7 is the argument, then my answer is 7. Because the exponent and the log cancel each other, and the argument is what's left. These two rules, in red and blue, make sure you write those down and they make sense to you. Those are the rules that we will be using today. So there are about 4 different types of problems that we're going to be using these properties on. Let's see how they work. Number 1. That's not number 1. Here's number 1. Let's see what this works. Part 1, solving exponential equations with the same base. Okay, this, we've always said that if I can have base 2 here and make this look like base 2, I can say the exponents are the same. And you've always taken me for granted that that's true. The question is why? Well, today I'm going to tell you why. First of all, can I write 128 as 2 to some power? The answer is yes. 2 to the x plus 1 is equal to 2 to the 7th power. Whenever we said that the exponents were the same, mathematically what we were really saying is log base 2. I take both of these to the log. Base 2 of 2 to the x plus 1 power is equal to log base 2 of 2 to the 7th. This is what I was doing behind the scenes, and I never really told you I was doing this behind the scenes. But the idea is here The log and the exponent cancel. The log and the exponent cancel, leaving x plus 1 is equal to 7. You subtract 1 from both sides, x is equal to 6. That is how we really were doing this problem without actually talking about how we do this problem. Can you think about it the other way? Sure. If the bases are the same, the exponents have to be the same. Why? Because I can go ahead and cancel out the bases and say log base 2 of 2. I can take this entire thing and stick it into the log, and take this entire thing and stick it into the log. Since the bases are the same, they go ahead and cancel out the log and the exponent. So let's try another one. And again, the idea stays the same. I want to go ahead and see, can I write both of these in the same base? And I can, because 4 to the 2x plus 3 is equal to 4 squared. Okay. In the same way, I can now say that log base 4 of 4 to the 2x plus 3 is equal to log base 4 of 4 squared. My logs and my exponents cancel. My log and my exponents cancel. I get 2x plus 3 is equal to 2. Solve for x. Subtract 3 from both sides. 2x is equal to negative 1. Divide by 2. X is equal to negative 1 half. Does that make sense? Does that work? Well, I don't know. Let's check it. Let's see. 2 times negative 1 half plus 3. Well, 2 times negative 1 half is negative 1. Negative 1 plus 3 is 2. So this is 4 to the second, which is 16. Hey, it works. So the log and the exponent cancel each other. Let's try this other problem. In this last problem, the question is, can I write these with the same base? And the first thing you're going to say, well, yes, because 4 times 2 is 8. But that's not the same base. I need to think of this 4 as 2 squared to the 3x power. And I need to think of 8 as 2 cubed to the x plus 1 power. Remember, power to a power, I multiply. So this is 2 to the 6x is equal to 2 to the 3 times x plus 1, distribute it through. So 2 to the 6x is equal to 2 to the 3x plus 3. Again, I can go ahead, since these are exponents, I can cancel out my exponents by doing logs. And so now I can say log base 2 of 2 to the 6x is equal to log base 2 of 2 to the 3x plus 3. Now, I haven't said much about this, but make sure you understand why I'm choosing these as base 2. I'm choosing these as base 2 because I already have a base of the exponent as 2, and they have to be the same for them to cancel out. So these cancel, leaving 6x. These cancel, leaving 3x plus 3. The exponents have to be the same. Solve for x. So I'm going to go ahead and subtract 3x from both sides. 3x is equal to 3, so x is equal to 1. If I go back to my original equation and plug in 1, I get 4 to the 3 times 1 is equal to 8 to the 1 plus 1. So 4 to the third is 64. 8 squared is 64. It checks out. That is how I do these problems. So the basis of how these work is that I had to have the same base. The bases had to be the same on these problems. What if my bases aren't the same? What will happen to my problems now? Let's look at a couple more examples. Solving exponential equations without the same base. And I promise you that does say without the same base. Well, let's try a couple of these. Well, I have a 2 and a 9. I cannot write 9 as 2 to some power. But, by the way, right now, if you don't have it, pause your computer, whatever you're watching on, and get out your calculator. When you're done with that, come on back. Pause. Unpause. So here we go. How do I do this problem? I have base 2 and a 9. Well, I want to get the exponent, the x, out of the exponent. I want to get the variable out of the exponent. The only way to do that is log base 2 of 2 to the x power. And that's equal to, well, if I do something to one side, I have to do it to the other. So this is log base 2 of 9. Well, remember, the log and the exponent cancel, so my left side is x. X is by itself. On my right side, what's this? Well, I don't care what this is. This is something I can put into my calculator. If I can put this straight into my calculator, do so. But if I need to do change of base, do log of 9 divided by log of 2. So x is equal to, bring up my handy dandy little calculator, slide it over here so I can see it a little better. Okay. And so I'm going to do log of 9, close parentheses, divided by log of 2, close parentheses. And I get 3.1699999, or 3.169925011, blah, 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 blah. Does this work? Let's find out. Let's take 2 to the, and I'm going to hit second negative to bring up my previous answer. And if I do that, I get 9. So it works. It checks out. So my answer for this, one more time, was, if I round to 2 decimal places, is 3.17. Wow! I can take a variable out of the exponent. That's huge, guys. You can never do that before. That's the purpose of logs. All right. Well, let's go to letter E. E to the x is equal to 7. I want to see what x is. Solve for x. So how do I cancel out e? I have to have a log base e. Well, log base e is natural log. So natural log of e to the x is equal to natural log of 7. Again, the log and the exponent cancel, leaving x. Natural log of 7. Well, I can plug that into my calculator. So I pull up my handy dandy little calculator. I slide it over to get it out of the way. I hit natural log, let's clear ahead, natural log of 7, and I get x to be 1.945. Again, that's my answer. X is 1.95 if I round to 2 decimal places. But check it. Does that make sense? E to 1.945910149 is that 7. So I'm going to hit second ln to bring up e. I'm going to hit second negative to bring up my previous answer. This should be 7, is it? The answer is yes. I find the number that I'm looking for. It works. So x is, rounded to 2 decimal places, 1.95. So now I've talked about solving exponential equations with the same base and without the same base. What about log problems? Let's look at some log problems. This first set of log problems, I only have log on one side. I don't have logs on both sides. How does this work? Well, we used to say, oh, I can change this to an exponential and solve. True. That's right. But at the same time, if I just wanted to solve the x in the form of a log, how would I do it? Well, I need to remember that b to the log base b of x is equal to x. This is one of the rules I gave you on the first page. I'm going to use it right now. I want to get rid of this log right here. And so to get rid of this log, I have a base 4. So I'm going to write this as 4 to the log base 4 of x plus 3. I just made my entire problem an exponent. What I do to the left side, I have to do to the right. The problem's not changed. It was all just made into an exponent. Nothing has changed. But notice what happens. I just said the word notice. Okay, what do I see next? Well, the exponent and the log cancel. So my left side is just x plus 3. My right side is 4 squared. Well, 4 squared is 16. Subtract 3 from both sides. X is equal to 13. If I go ahead and work this out, and I check this, log base 4 of 13 plus 3, well, this is definitely log base 4 of 16, which is log base 4 of 4 squared, which, as we said earlier, is 2. So this checks out. This checks out. Wow, how powerful. I can go ahead and solve log problems without, granted, I'm using an exponent, but I'm not making it an exponent. I'm just using the exponent. Let's look at letter G. Okay, I have log base 2 of x plus log base 2 of x minus 3, x minus 7 is equal to 3. Well, before I can do a log, I want to go, before I can throw an exponent at this and use this rule that I have up here, I want to condense this. So to condense this, I'm going to say log base 2 of, and whenever I'm adding, remember addition does become multiplication. So log base 2 of x times x minus 7 is my new left side. Log base 2 of x times x minus 7 is equal to 3. Now that it's one log, I can go ahead and write this as an exponent. So I can say this is, well, my base is 2, so I want to say 2 to the log base 2 of x times x minus 7. Well, that's equal to 2 to the third. If I take 2 to some power on the left, I have to do 2 to some power on the right. So my bases are the same. What I do to the left side, I can also do to the right side. 2 to the power on the left equals 2 to the power on the right. My log and my exponent cancel, so I'm left with x times x minus 7 is equal to 2 to the third. 2 times 2 is 4, times 2 is 8. Solve for x. Now, this is a fun problem. This is an exponential. Distribute the x. I get exponential. This is a quadratic. I get x squared minus 7x equals 8. Subtract 8 to both sides. X squared minus 7x minus 8 is equal to 0. What multiplies to be negative 8 and adds to be negative 7? Oh, well, that's going to be x minus 8, x plus 1. That's not a 1. Plus 1. That's x squared plus 1 minus 8x. That's minus 7x minus 8. So then that tells me that x minus 8 is equal to 0. X plus 1 is equal to 0. So x is equal to 8, or x is equal to negative 1. Well, what's my answer? Can I have more than one answer? Let's go back to the top and find out. Are either of these extraneous, or are they both going to work? I have 8 and negative 1. So up at the top, I want to do log base 2 of 8 plus log base 2 of 8 minus 7. And I want to see if that equals 3. Well, log base 2 of 8, this is log base 2 of 2 cubed. So this is 3. This is log base 2 of 1. And pause or station identification. Log base anything of 1 is always 0. So this is equal to 3. Now you said, wait, log of any base equals 1 is log base 2 of 1 is 0. Why? Well, that's because 2 to the 0 is 1. So log base 2 of 1 has to be 0. They switch back and forth. So that is my answer. 8 is a good answer. What about negative 1? Let's check out negative 1. Okay. So log base 2 of negative 1 plus log base 2 of negative 1 minus 7 is equal to 3. Well, this is where problems start happening, because here, log base 2 of negative 1, this doesn't exist. There's no solution. Remember, x has to be greater than 0 for these problems because of that, because in that particular one, x has to be greater than 0. Here, x has to be greater than 7. So again, this would give me no solution. This would give me no solution. So this doesn't work. So the answer, this is not a good answer. Negative 1 is an extraneous answer. So the only answer that works is x equals 8. So that's 3 different ways of doing this. 3 different types of problems. Is there a 4th way? Yes, this is the last type of problem I might give you when it comes to solving. And it has logs on both sides of the equation. First thing that you have to see, notice, realize, understand, and value, for lack of a better word, is that whenever I give you this type of problem, the bases of the logs have to be the same. If the bases of the logs are not the same, I'll have to do some investigation, but at this point I don't think we can do much to it. It's hard to change the base. Could we do some stuff? Yes, but then you're doing logs of logs and it gets confusing, and we won't go into that in depth. So at this point, I have a log on the left, log base 7, and log base 7 on the right. So I'm going to do 7, and now this is my entire exponent of log base 7 of 2x minus 1 is equal to 7 to the log base 7 of x plus 5. Okay, I didn't need that extra parenthesis. Let me fix that. This is log base 7 of x plus 5. Once again, the exponent and the log cancel, not just on the left side, leaving 2x minus 1, but also on the right side, since there's logs on both sides, leaving x plus 5. All you do now is solve for x. Subtract x. X minus 1 is equal to 5. Add 1, so x is equal to 6. So if I plug in 6 here, 12 minus 1 is 11. 6 plus 5 is 11, so log base 7 of 11 equals log base 7 of 11. It works. It checks out. There's my first problem. And the last one is natural log. So again, the base of natural log is e. So I want to go e and e. So e to the natural log of x plus 3 is equal to e to the natural log of 8x plus 17. Once again, the log and the natural log, the exponent and the natural log cancel. So I have x plus 3 is equal to 8x plus 17. Subtract x. 3 is equal to 7x plus 17. Subtract 17, negative 14 is equal to 7x. So x is equal to negative 2. Let's check this to see if this makes sense. If I plug in negative 2 here, which is the natural log of 1. If I plug in negative 2 here, this is the natural log of 1. So the natural log of 1 is equal to the natural log of 1. But if you go and you pull out your handy-dandy little calculator, the natural log of 1 is 0. But it does check out, nonetheless. The natural log of 1 is equal to the natural log of 1. X equals negative 2. Checks out. There's my answer. 4 types of problems. We'll be working on this for about a day, maybe a day and a half, and then we'll start some review as we head towards our test. We'll talk about that in class tomorrow. Have a great day. Less than 25 minutes. Ha ha.